Oh, is it not going up there? Okay, awesome. Hi, my name is Lita. Thank you so much for coming to my talk. I'm here to talk about so my name is Lita. I'm the founder of Moment, and our product, we did a migration over to Tauri libgit2, and I wanted to give a talk about that. So what we'll cover is like, why do we even do this? Why did we migrate? Like, we started off as an Electron app and did this migration, and we looked at other options to avoid it as much as possible, but turns out through investigation, that was not the right path for us. And we'll, at the end, go over the migration path and take the results. And my hope is that if you're considering making a Git tool with like a UI or desktop app, to consider using Tauri Request. I think we had like a lot of success with it, and we'll love to like just share those success with you all. And then also, if you decide that's not the right path for you, leverage the findings and investigations that we did so that we could save you some time ultimately. So yeah. So just a brief context of who I am. I have a big passion for making tools to make people more productive. So I started off my career at DreamWorks Animation making tools for artists. So in the lighting department, I ended up building like scripts or plugins within our internal tool to make the artists like do their job more effectively or make render times more performant and things of that nature. And then after that, I ended up switching over into tech and started my tech career at Lyft, saw it go through hypergrowth. And there, I ended up leading the networking team and maintaining and building tools around the service mesh, specifically around Envoy and our front proxy, and making sure app developers were productive and not needing to worry about like our IP addresses or like how to discover our new hosts that are coming up. Like make that all out of the box and just like have the app developers just focus on writing business logic and just knowing the name of their service that they want to talk to, and it just all magically works. And from that experience, I ended up founding a company with my co-founder, Moment, where a lot of times I think I felt the pain of not being able to share my expertise around networking in a codified way. Like, I don't think it's reasonable to teach everyone the deep depths of all of networking. And so how do we codify that and make tools around that more easily and more productive and quicker? Because I'm not an expert on making UIs and like interactive tools. So like my co-founder and I decided to found Moment and try to solve that problem. So a brief context. Before we can dive into the problem exactly, like I wanted to give a quick demo of what Moment does, and that way you could get an idea of like what the decisions that we made throughout the talk. Moment ultimately what Moment is like a local first program, like creates programmable documents that are interactive and local first. So at the end of the day, all these documents are marked down. And so, does this work? Okay, I'm gonna put this away. And I'm gonna hope the demo gods are kind to me because this is gonna be a live demo. So here, this is our staging environment. Ultimately, a Moment document is a Git repo. So the entire document is a Git repo. And under the hood, it's markdown. So like, what gets saved into disks is markdown syntax. And as you can see, we have like, we load that up and render that in a nice way, but under the hood, it's markdown files at the end of the day. You can make to-do lists, you can make bullet points, you can bold and do normal human writing, along with like formatting nice code, like const hi. But that just, it makes it a normal text editor. So what makes us different, I would say, is you can program in it. So actually, let's make a new page called code cells. And down here has some like boilerplate things you can start off with. So here you can, this is actual JavaScript, and we're actually rendering and compiling that JavaScript and displaying the end result for you. And so for example, you can make a HTTP request. Here's some boilerplate JSON. You can explore that JSON data. And then from here, kind of like Jupyter Notebooks, every code cell gets a name, and that name is referenceable. So we can do something like get filter, let's see, item, so let's say item. The item has a weight, so anything greater than 80, return that. And then that should give you only the items that have a weight greater than 80. And so the idea here is that you could, play with your data and then put it into a nice UI. And then the data, if the data changes, you don't have to update the doc. The doc just changes with you. So here's an example of we make a GitHub API PR request. This is open source, so it's public, and so we're querying the Kubernetes, all the pull requests from Kubernetes, and then feeding that data into a component and rendering that nicely. So under the hood, this is like a React component, and as you can see here, we're just passing the data in here. So that's what Moment does. And so we're also very collaborative. So people expect documents to be like Google Docs, kind of live collaborative, have live collab editing. And so we do support that. So here, let's say that this is my local instance, but assume this is like a separate computer. So I can live code, shows in both spaces. And if I want to insert a code block, that should also show up in this other side if the code gods are kind to me. Yeah, so it takes a little time, but the code cells reflect in both sides as well. And the other thing that makes us different is that we are natively support Git. So you can then commit this, and the diffs that they show are you see the diff in Markdown. And so as you can see, you could commit this, and then if you go back, you could see the history of, I am not very organized, so I don't have nice descriptions of any of my commits, but you could then look through the diff and see what was changed in this living document. So people did creative things in my team, someone put an emulator here of Zelda, that's cool, but a more realistic example is a release canvas. So this document is how we release to production. I obviously copied it over. He has some instructions on how to use this and how to set it up. You have to use a GitHub access token, but that is not saved in here. And that how we do that is not in scope for this talk. But if you want to chat about it, happy to discuss that. Here's a bunch of internals, but at the end of the day, we could see a list of commits that would need to go out. So they're in main, but not in production. And if I were to, I could then run a release, and that would generate a new production release and update all the, auto-update all the users with our new update, but I'm not going to do that. So that's essentially what Moment is in a nutshell. So going back to the talk, so we initially start off as an Electron app. So we had all of that working in Electron. We chose Electron because it was very mature. Slack is the biggest Electron app that is used today, the Slack desktop app. GitHub desktop app is open source. It also uses Electron. And so this is what our architecture looked like. It was the main process is run in Node.js, and then there is a render process that's running Chromium, and Electron bundles Chromium in the desktop app so that and that's how it renders your web app in the desktop. And that is messages get passed via the IPC inter-process communication, and we ended up needing to build another Node server that has a WebSocket open to do the Git commands. So the render process communicates to the second Node server to do the Git commands like git commit, git status to render this like UI. So like this UI is calling Git status and Git, or like in the old version, in the Electron version, that's what it was doing. And this, which at the end of the day, it's a simple Git shells out to the user's Git client. So there's many things that went wrong with this. Like the first thing was like the main thread halting. So before, the reason why we need to make this second node server was because anytime you put in any Git commands into the main process, the UI will halt. So as a text editor, that's not really acceptable. Like as you type along and you, like in the background process, you do a Git status and all of a sudden it halts. That's a terrible product experience. And so that's why we went with spawning another node server. We looked into using node workers, but it turns out like you lose type safety with that. And so we ended up doing a long list server. But there was also issues like the server would die randomly, so we started needing to help checking it and restarting. And Electron doesn't really give you good tooling to like monitor different processes and the health of the different processes. You would have to build that all on your own. The second issue that we ran into is the dependency on the user's Git client. So people run various versions of Git. If you were to download, at the time when we were doing this, if you were to download the default Mac OS DevTools Git version, it's very old. And so that didn't provide, there was a lot of bugs that we would have to solve to handle different varieties of different Git versions. We could have asked users to upgrade before installing, and there's a lot of dev tools that do that, but we didn't think that was a great product onboarding experience. And then lastly, the other annoying thing we had to do was that we would have to we do provide a way for you to sync, so if you can publish your moment document to the cloud, and we will store that Git remote for you in our server. And in order to do authentication, we would have to store your auth token in the Git config as a header. That's not, and we would, every time we do a refresh token, we would write that to your Git config that's stored locally into your moment repo, like the moment's repos Git config. But that access token is not revocable. It does expire very quickly, but it still didn't feel great that we had to have that data leave the scope of the app. So that was another reason why the Electron app solution wasn't great. So there's a variety of solutions we tried first before migrating out of Electron. Our team, our backend and our Git server is running Go, and so we have a lot of Go expertise. So we looked into using, and there's a bit of benefit of replacing just this WebSocket node server part with a Go server. One of which is that you could use real locks for file writes and then Git commands will be guaranteed to be run in order. Also, we could, in theory, share code between the remote Git server and our client. So we looked into go-git, which is a pure Go implementation of Git, and the unfortunate thing is they don't have rebase implemented or merge, and that is critical to our roadmap. And we want to control. We want to handle conflicts, and we want to merge appropriately and rebase appropriately. So that was not going to be feasible. And we also look into Gitly, which is GitLab's core. This is what runs on their server, which is pretty nice. And the unfortunate thing is they too don't really implement merge or diff. They shell out to a Git CLI. And that works for them because they're running Gitly in the server and can control their client, but that won't work for us, again, because we're running on users' client laptops or computers, so we don't have control over the Git client. So that wasn't going to work either. So yeah, I feel like this audience is well known of libgit and how awesome libgit2 is. So in order for Git to be a core in order to have a great product experience, Git was core to the product experience. And so at the end of the day, we had to integrate with libgit2 in order to control, because we did need that full control of that developer experience. The advantages here is that we no longer have to write the access token into the Git config anymore. That's all stored in runtime. We could have full control over the merge experience. We could, there's also ways to like plug in and have your own custom merge algorithm if you want to. Like Markdown has different algorithms that might be better than like for code per se, but we have not explored that deeply yet. Also, we get to leverage a system level language similar to Go in the sense that we will have true concurrency, have real locks, and that kind of control is nice when you're messing with the file system. The concerns, though, is that our team is not, they're not, they're all full stack developers. There's no one's a C expert other than me and my co-founder. I think we're the only ones that had like production level C and C++ experience. So I was concerned about like, can we debug segfaults? Can we onboard full stack engineers to libgit2? Can we ship at that high velocity with that at early stage startup needs to do? So the various options we explored, one was Zig. Zig is relatively new. I mean, it's not that new. It's like, was released in 2018, but new in the language like years. And what's nice about Zig is that the syntax is pretty small. The entire like syntax is specified in this like small 580 line PNG grammar file. Projects that use Zig successfully are Ghost T, I don't know how to say it, Ghost TT, and Tiger Beetle, which is a database that handles financial transactions. What's nice about Zig is that it compiles very fast. It's like just as fast as Go. I have not timed any of these things, but it is one of the faster build systems I've used. And what it was trying to solve is like there's no hidden flow control. So all the memory allocations and freeing is defined. So debugging is much easier. Like debug in the sense that like if it is very explicit where memory is being allocated and where it's being free. There's no like hidden. The compiler doesn't inject any memory commands, and what you see is what you get. The other powerful things Zig can do is that you can plug in C and C++ code directly into their build system. So you could just plug in libgit2 and start calling the methods that they expose in the header file. And then the biggest benefit is that we wouldn't have to leave Electron like that. We could still the Electron still stays the same. We're just swapping out that secondary node server with this server. The downsides are obviously it's not fully memory safe. And it's not as mature, so there's less resources for learning. As I started integrating and prototyping with Zig, I think the biggest downside, it was, again, the segfaults. Like debugging segfaults and asking our team to do that, it was a big ask. So like, this is what it would look like if I just do something simple like, oh, here I think I try to pull, do a git fetch on a repo that didn't have an origin set up, and this is what the segfault looked like. This is not a great developer experience, and so that was like the downside of just integrating with Zig and libgit2. The further downsides are that the Electron's app was still pretty bloated. It's really heavy. Like, yes, you save a lot of time on building the Zig compile time, but like still like working within Electron was still heavy and slow, and then the binary itself ended up being pretty big as well. So the option that the second option we looked into was Tauri with Rust, and then using libgit2 within Rust. For those of you who don't know what Tauri is, it's a framework that creates a variety of types of applications, like mostly for desktop, but they also support mobile. It was built with a Rust core as the main thread, and it leverages the operating system web views rather than bundling with Chrome or Chromium, and that's how they're able to reduce the bundle size of your application to drastically smaller than an Electron app. And the ethos of that project is that they wanted to make it easy for developers to make smaller and faster and more secure desktop applications. And famously, like Git Butler is a big user of Tauri, as well as this cool like little networking tool called Yak, which I really love. The benefits of Rust is obviously memory safety. So unless you put unsafe everywhere, you're unlikely to get seg faults. And most of the issues you'll run into is compiler time. And what's nice with Rust is that they give you a lot of hints and helpful error messages to unblock you. It's also much more mature than Zig, so the Rust book is really helpful to teach you about how the Bower checker works and all that jazz. So as we were integrating and with Tauri and prototyping with Tauri, we noticed like the app kept getting more and more performant because we were using that native OS browser, WebView/browser. And what's also nice is that since Tauri uses the OS WebView, you get the benefits of users doing security updates. So whenever a user does a OS level upgrade, like your app is benefiting from that. Like unlike with Chromium, if there's like a security patch that's sent out everywhere, you have to ask users to auto upgrade or release another version. So it is inherently secure in that sense. The other really nice thing about Tauri is that it does not use the network stack to communicate between the main process and the render process. So it leverages native bridges and hooks into the OS level callbacks in order to communicate between the different processes, and it's contained all within the Rust application, which is pretty nice. So there's no open port you expose, and yes, there's ways to like prevent like the port being found by using random ports and whatever. But the fact that it's all isolated in the Rust app is pretty nice. It is designed with security in mind. Web views can be rendered in an iframe. We do not do that because in order to make that work, then you have to be explicit about what dependencies that render frame needs. It's just more overhead. But if security is really important to you, that mode is pretty good. And then also permissions are explicit, which is really like in Node, feel like Node is more permissive, like you get access to the entire file system, and in Tauri, that's like the opposite. You have to be explicit about what access you want, specifically around if you want read and write access to the file system, if you want access to notifications, and that sort of thing. And also every major release of Tauri is security audited. And even though it's early, and even though it's relatively new or new-ish compared to Electron, the open source governance is pretty good. So the downsides are, like, again, the downsides is we need to remake the new build pipeline. We had a build pipeline working, and now we have to set that all up for Tauri. And then we weren't sure how this was going to work with multiple browsers, like supporting Safari, Chrome, and for Windows, and I believe it's WebGKT for Linux. And so there's a wider testing coverage was needed. But yeah, so again, what we discovered for like the developer experience and shipping features, the compiler is a much friendlier way to interact with memory. And so even though we moved over to like a system language where you can manage your own memory, Rust compiler is a much better onboarding experience. And so, and it was surprisingly, even though people were worried about the Bower checker being a sharp learning curve, and yes, there is some learning curve. It was not as bad as I anticipated, and the whole team was able to be comfortable writing like Tauri Rust code along with JavaScript, and when at the end of the day, after we migrated, the binary is a lot smaller, which means that the auto upgrading is a lot faster of an experience, and the typing speed got a lot faster, and initial load times were noticeably faster. And this is what I mean about the permissions being explicit. You have to explicitly say that I want to allow people to access the home directory, and also I will like read and write access to specific user space directories. And then if you want to do copy and paste, you also have to be explicit about wanting access to the clipboard as well. We didn't run into that many cross-browser issues, actually. It ended up being relatively smooth. The only main issue was the copy and paste. We had to re-implement that in various different ways for Safari, but other than that, it kind of worked out of the box, which was really surprising. The other thing we ran into was that we had to we were not able to use the Tauri write plugin, and you can't overload that or add middleware to that for security reasons. So at the end of the day, we just had to write that ourselves because we do want to use a lock along with these libgit2 commands. So like whenever libgit2 is doing git status, we can't be writing to a file because that would cause a crash, and specifically in macOS. So I mean, yes, that's a little bit annoying, but it was not as bad as I thought it would be. And auto-updating and moving over a build system was actually not that bad. We thought it would be terrible, but in the end of the day, auto-updating is a first-class citizen in Tauri, so all you have to do is just register where to find the URL and signature of like your new app, and then how to determine and the public certain signing key to say that this app is who you say you are, so it's not downloading malicious applications. And then it all just works out of the box, which was super surprising. So yeah, TLDR was that if it was like Electron and then like we were replacing with Zig or Rust, I don't think that wouldn't gain us very much, but Tauri itself was the biggest benefit, and the framework gives you a lot in a much more secure way and a better performance experience, especially for a text editor where typing speed matters. So yeah, at the end of this is the end result. So now we have a Tauri desktop client where the core main process is in Rust, which handles all the windowing life cycles, and then the Git commands are not in the core main process. It spins off a command process that's short-lived that calls Git, libgit2, and if it's doing a Git push or a Git pull, all the authentication tokens live in runtime, and the render process uses the CropsForm rev view, and you can still use fetch from the render process, but all that does is call to our internal APIs to fetch document data to render out like the list of documents you have access to and things like that. And in our backend, we still use our Go that hasn't changed. We still use our Go proxy, and then that proxies we use Git under the hood for your remote Git servers. So yeah. So that's the end of my talk. If you have questions or want to discuss further about any of this stuff, happy to chat. Feel free to contact me, or you're welcome to join our Discord. Also, feel free to try out Moment. It is still rough around the edges, but we'd love for you to try it out and give us your feedback. So thank you.